And the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 10 test, which is due by 11:59 tonight. So, what do you got for me? Questions? Anything? Anybody?
Can you do 10 and 12 from the review last night?
10 and 12 from the review last night. All righty. Let's bring that up and we will take a look. Okay. Do you want me to do your specific 10 and 12 or just any of them?
If you could do mine, that'd be awesome. This
All
is
right.
David, by the way. So
It's who?
Davis from your map.
Okay. Davis, let's see here. Where are you? You must be in the other class. Let's see here. And, whoops, that's not it. Let's try that again. Okay. Here we go. Okay. So from the chapter review, you said?
Yeah.
And number 10 and 12. All right.
Yep.
Okay. Let's see here. Let's do this. Okay, this is going to take me a minute here, but let's put that here. I'm going to put them side by side so that we can see the problems as they're worked out. Okay, so now, can you see WebAssign on the left and the whiteboard on the right?
Yep.
Awesome. Okay. So number 10 says solve the equation, approximate the solutions to two decimal places. So the equation is t, all right, what's going on here, folks? T squared equals t plus 4. So the first thing I'm going to do is I'm going to get everything on one side of the equation, and I'd like to have my leading coefficient, that is the implied one in front of t squared, to be positive. So I'm going to subtract t from both sides, and I'm going to subtract 4 from both sides. So I get t squared minus t minus 4 equals 0. Okay? Now, based on that, a is 1, b is -1, and c is -4. So now I get t equals -b plus or minus the square root of b squared minus 4ac all over 2a. And as I'm going along, if you have any questions, jump in, stop me, say, hold it, what'd you do, what's going on? Okay, so t equals negative times negative is a positive 1, plus or minus the square root of. -1, the quantity squared, is a positive 1. And then minus 4 times 1 times minus 4 would be plus 16 all over 2. So t equals 1 plus or minus the square root of 16 all over 2. It says solve the equation, approximate the solutions to two decimal places. So t is going to equal 1 plus the square root of 17 all over 2. And 1 minus the square root of 17 all over 2. Now, the entire numerator gets divided by 2. So when I go to put this into my calculator, I'm going to go parentheses 1 plus the square root of 17, close parentheses, divided by 2. And at least on my calculator, let's see here. Where'd the mouse go? Here you are. There's going to be another set of parentheses right there. Okay. So put that in a calculator. I've got parentheses 1 plus the square root of 17. I close that up, close up the entire numerator divided by 2, and I get 2.56155, etc., etc. Rounding to the nearest hundredth, we get 2.56. All right. Now, the second one. Putting that in the calculator, 1 minus the square root of 17 divided by 2. And again, I'm going to have another second set of parentheses there. That's a 17. It kind of looks like a 7, but it's a 17. Okay. So putting all that in, I get negative 1.56155, etc., etc. So that becomes negative 1.56. Okay, did you figure out what you did wrong? Maybe
It was an error on the calculator.
Okay, calculator error.
Yeah.
All right, and then you said number 12. So let's take a look at that one. And here, use the quadratic formula to solve the equation. So we've got x squared divided by 8 minus x divided by 4 equals 1/2. So I have an equation containing fractions. It would be easiest to clear the fractions by multiplying both sides of the equation by the least common denominator, which is 8. So I'm going to multiply the left side by 8 and the right side by 8. I'm putting the 8 over 1 just to emphasize that that 8 is in the numerator. So here I've got 8 times x squared over 8, which reduces down to x squared, minus 8 times x over 4. The 8 over 4 reduces to 2 over 1, so minus 2x equals, and 1/2 times 8 over 1 reduces down to 4. So that's clearing the fractions. Next, I'm going to subtract 4 from both sides of the equation so that I have an equation in descending powers standard form to plug into the quadratic formula. Any questions so far?
Nope.
All right, so now A is 1, B is -2, and C is -4. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Simplifying further, X equals negative times negative is a +2, plus or minus the square root of -2 times -2 is +4, and then we've got -4 times 1 times -4, which is +16, all over 2. X equals 2 plus or minus the square root of 20 over 2. Okay. Now, it doesn't say anything about decimal approximations, so I want the exact answers, but I want them simplified as far as possible. So I could take this and I could split it up like this. But I can do something further, because the square root of 20 is the square root of 4 times 5, which is 2 square roots of 5. Okay, so the square root of 20 becomes 2 square roots of 5. Now the 2's will reduce out. Oops, I left off the minus there. So now we've got 1 plus or minus the square root of 5. Yeah, just the square root of 5. So 1 plus the square root of 5, comma, 1 minus the square root of 5. This came up yesterday. A student had a question, so I wanted to remind you. You want to make sure that this comma is moved outside of the radical. For instance, if you do it like this, it's confused. It thinks that all of this is one answer, and it doesn't know what to do with that comma inside. So you've got to make sure to move the cursor or whatever to get that comma outside. But anyway, those would be your two solutions. All righty.
Yep. Thank you.
You bet. All right. What else? What do we got, folks? Bring it on. Well, let's do this then. Let's go back and take a look at highlight some things in chapter 10. Let's see. So 10.1, we looked at the square root property. Okay. The idea there was that you got things in the form of a perfect square equals a constant. And we had, we'll say, variable inside. So we've got a perfect square that contains a variable. It can have other numbers as well, equal to a constant. So for instance, let's say we've got this. Hang on here. 8x plus 5, the quantity squared, equals 24. So this problem is already in that form where we've got a perfect square on one side of the equation containing a variable equal to a constant. Okay. So when it's in that form, we're going to take the square root of both sides. Don't forget the plus or minus on the right-hand side. So now we've got 8x plus 5 equals plus or minus the square root of 24. We're going to subtract 5 from both sides. 8x equals negative 5 plus or minus the square root of 24. We're going to divide both sides by 8. X equals negative 5 plus or minus the square root of 24 over 8. However, we can take the square root of 24 and break it down into the square root of 4 times 6. The square root of 4 is a 2 outside. So this goes right there. X equals negative 5 plus or minus 2 square roots of 6 all over 8. Okay. The next step, this one, it said to also approximate it to nearest hundredth with a calculator. So x is negative 5 plus 2 square roots of 6 all over 8. X is negative 5 minus 2 square roots of 6 all over 8. So here again, we're going to put parentheses around the whole thing as well as around the square root of 6. And then here, the same thing. Divided by 8, and let's see what we get there. So parentheses negative 5 plus 2 times the square root of 6. Close it, close the whole thing, divided by 8, and negative 0.0126, etc., etc. So this becomes negative 0.01 because the 2 would round down. So there's the first answer. And then the second answer, let's see here, we get negative 1.23737, and the 7 would round up, so we're going to get negative 1.24. And let's see. So we've got the exact answers and their decimal approximations. All right, so that's the square root property. Then section 10.2, we moved into using the quadratic formula. You should have the quadratic formula memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so to use the quadratic formula, you have to take an equation and put it in standard form. Let's see here. Let's do this one. X squared over 2 plus 5 over 2x equals -1. Okay, so I'm going to clear the fractions by multiplying everybody by 2. So I get x squared plus 5x equals -2. Adding 2 to both sides of the equation, x squared plus 5x plus 2 equals 0. Okay. So A is 1, B is 5, C is 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25 minus 8 all over 2. X equals -5 plus or minus the square root of 17 all over 2. And so let's see here. Where did that one go? What are we supposed to do? Are we supposed to? Yeah, they also want us to approximate it to the nearest hundredth. So x is -5 plus the square root of 17 over 2. Again, we're going to quantify the whole numerator as well as the radical. So parentheses -5 plus the square root of 17 divided by 2, and I'm getting -0.438. So that's going to round up -0.44. And then the other one, we get, let's see here, -4.561. So -4.56. Okay. And let's see, anything else there I want to do? If you have decimals, multiply through to clear the decimals. Otherwise, you get really nasty decimal numbers inside the radical, and it's just nicer to clean it up first. Anything to do with section 10.2? Anything else beyond that you want to look at? Okay, then let's go on to 10.4. 10.4, I want to remind you about, let's see, how to graph parabolas. So let's take a look at that. Okay, I'm going to switch over to just this screen for a minute. And let's see here. Put that over there. Home. View. And let's see. Let's go with chapter review. I want to make sure I'm getting to something where I can actually write on it and you can see it. Yeah, here we go. Okay. So now let's go back to where you can see the WebAssign as well. All right, so we had two different forms of quadratic equations. We had the one that was in this form, which was y equals a times x minus h squared plus k. and the axis of symmetry is at x equals h. The vertex is at hk. If a is greater than 0, it opens up. If a is less than 0, it opens down. So let's take a look at this problem 16 here. So h would be 1. So your axis of symmetry is going to be at x equals 1. Again, if you just put in 1, it's wrong. You've got to write x equals it for the axis of symmetry. The vertex is going to be at h, k. All right. A is an implied 1 out front. So since a is positive, it opens upwards. Okay. So that's what that would look like. Any questions about that particular problem? Okay, let's do another one. So here, h is -3. It's the inverse of what's inside. So x equals -3. Your vertex is at -3, comma, -4. A is negative, so it opens downwards. All right. Any questions about that? Okay, let's do another one and then we'll graph this thing. So the axis of symmetry is at x equals, see, h would be -7 because x plus 7 would be x minus -7, inverse of what's inside, so -7. The vertex is at -7, comma, space, -2. I always think it's weird that they ask for the vertex first because technically you find the axis of symmetry before you find the vertex. All right, so now I got to graph this thing, okay? And recall when you're graphing a parabola, okay, you got to click on this till it turns blue. You start with the vertex and pay attention to the scale. In this problem, every increment is in 2 units. So -7 would be halfway between -6 and -8. -2 is right there. Now, I need a second point. So let's go over here and let's take a look at f of x equals x plus 7 squared minus 2. Okay. And we know the vertex is at -7, -2. So let's just pick a point that's, immediately to the left or right. How about -6? So f of -6 would be -6 plus 7, the quantity squared minus 2, 1 squared minus 2, 1 minus 2, -1. So after having plotted the vertex, a second point, -6, -1 is right there. Now, if I'm not 100% sure I've plotted my points where I want them, I can check here, -7, -2, -6, -1, and I can change those by going in and literally changing it. So let's see if I've got everything correct there. And it is. All right. Any questions about that? Let's do another one of those. Let's see what else have we got here. Yeah, let's do another one here. So for this one, let's see, the axis of symmetry would be at x equals 7. Okay, and the vertex is at 7, comma, what's k? There's nothing out here, so k is 0. All right. So we've got this f of x equals negative times x minus 7 squared. So y equals a times x minus h squared plus k. So k is a 0. Okay. So we're going to plot the vertex, which is at 7, 0. And again, notice that the scale here is in 2s. So 7 zeros right there. And then I need another point. how about 8 comma whatever? So f of 8 is negative times the quantity 8 minus 7 squared, which is negative times the quantity 1 squared, which is negative 1. So 8, negative 1 is right there. Let's see it. 7, 0, 8, negative 1. Looks good. Okay. So there's graphing it in the form of y equals a times the quantity x minus h squared plus k. All right. Then we had the second form, which was this. And we also introduced finding x and y intercepts. And to find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. So let's take this problem. F of x equals x squared minus 2x minus 15. Okay. So to find x-intercept, set y equal to 0. So we get that. We'll use the quadratic formula to solve this. A is 1, B is negative 2, C is negative 15. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is 2 plus or minus the square root of 4 plus 60 all over 2. X is 2 plus or minus the square root of 64 all over 2. X is 2 plus or minus 8 all over 2, which is 2 plus 8 over 2, 16 over 2, which is 8. 2 minus 8 over 2, negative 6 over 2, negative 3. So your x-intercepts are going to be at 8, 0, negative 3, 0. But keep in mind, it asks to put the smaller ones first. So we're going to put the negative 3, 0, and the 8, 0. Make sure that you put in both coordinates, the x and the y value. Also make sure you use a comma and not a period. These are all mistakes I've seen people make. All right, the y-intercept, to find the y-intercept, you set x equal to 0. Well, if we find f of 0, that's just going to be, that's supposed to be a squared. That's just going to be the c value, right? So that's going to, so it's at 0, negative 15. So here again, 0, negative 15. Okay. Oh, I've got a mistake. What did I do wrong? It says that one's wrong. Okay. Oh, look at my mistake. 2 plus 8 is not 16. It's 10. I multiplied instead of divided. Okay, so I got to go back here and erase this. Okay. Good thing it's not that I'm not taking the test, huh? Okay. So this is going to be what? 10 over 5 or 10 over 2 or 5. So I come back over here and change that to a 5, and let's see what happens now. There we go, that's better. So you really got to be careful. I have to keep telling myself, slow down. I always get in a hurry, make sure I get through everything. Not a good game plan. All right, let's see here. Let's find one where we have more than one x-intercept. Surely there's, well, maybe there isn't any. Let's see. I'm trying to find one that we're going to graph that has 2 x-intercepts, but I guess there aren't any here. But let's go ahead and do this problem. So f of x equals x squared minus 10x plus 25. Okay. And we're supposed to find the vertex. Well, let's see. This is in standard form. A is 1, b is negative 10. X equals negative b over 2a. So there's a formula you need to have memorized, which is negative times negative 10 over 2 times 1, which is 10 over 2 or 5. So the axis of symmetry is at x equals 5. They didn't ask for that, but I need to find the x value of the vertex, right? So then f of 5 is going to be 5 squared minus 10 times 5 plus 25, which is 25 minus 50 plus 25, which is 0. So the vertex is at 5, 0. 5, 0. All right. Now, X-intercepts. So I'm going to, let's go back up here and say that C is equal to 25, right? So A, B, and C. So if I set this thing equal to 0, and here's my A, B, and C values that I'll plug into the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X is 5. Oh, no, I'm getting ahead of myself here. It's going to be 5 eventually, but not yet. Okay. X is 10 plus or minus the square root of 100 minus 100 all over 2. X is 10 plus or minus the square root of 0 all over 2. X is 10 plus or minus 0 over 2. X is 10 over 2. X is 5. Oh, so the x-intercepts are at 5, 0, 5, 0, which is just 5, 0. So the x-intercept, there's only one of them. Why is that? Because the vertex lies on the x-axis. What's the y-intercept? Well, if x is 0, the y-intercept would be 25. So 0, 25, right? Okay, so let's graph this thing. Vertex is at 5, 0. Oh, my increments are in 3s, so I'm just going to kind of put it there, and I'll check it here in a minute. And then 0, 25 would be about there. All right, let's see. 5 zeros. Oh, nice. I hit it right on. Okay. And if I didn't, I could adjust it. So let's see what happens. And there we go. All right. Do you want to look at any application problems from chapter 10, section 4? Anybody? Anything?
I wanted to look on the review, the building with the ball one.
This one?
Yes.
All right. Is it okay if I do this one, or do you want me to do the specific one that's in your assignment, which may be different, may not?
That one's fine. I just need to figure out like how to like input it and all of that.
Okay, so let's take a look at this one. All right, it says, from the top of a building, a ball is thrown straight up with initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball t seconds after it is thrown. Find the height, the maximum height reached by the ball, and the time it takes for the ball to hit the ground. Okay, so over here in our picture, the maximum height would be up here, right? Well, think of this graph, or this, the path of the ball is parabolic. It's a parabola. So right up there would be the highest point, okay? That would be the maximum height. So that would be the Y value of the vertex. And then it says find out when it hits the ground. So that when it hits the ground, that would be when the height is 0, what time is it? So we want the height here and the time there. Okay. So the graph of this thing is a parabola because it's a second degree equation, right? And it's going to open downward because the leading coefficient is negative. So again, we've got this picture. We're looking for the vertex, which is in the form t comma s. We want the maximum height. So we want the s, or the distance, the height of the vertex. Okay. Well, let's see. If we use x equals negative b over 2a, and let's see, a is negative 16 and b is 32. So that's going to be negative 32 over 2 times negative 16, which is negative 32 over negative 32, which is 1. Okay. So it reaches the maximum height after 1 second. So what is the height when the time is 1 second? One squared is 1, and times 1 or times negative 16 is negative 16, and then 32 times 1. So what do we have there? We have 64. So our vertex is at 1 comma 64. So the time, 1 second later, the height, 64 feet. Okay, so 64 feet. But we don't want the time that it reaches the height, the maximum height. We want the time for when it hits the ground. Okay, well, when does that happen? When the height is 0. So we're going to take our equation and set the height equal to 0 and find out what time is it on the ground here. Okay, well, let's see. We could make these numbers easier. We could divide everybody by 16, or if we divided everybody by negative 16, not only would we make the number smaller, but we'd have a nice positive leading coefficient. So negative 16 over negative 16 reduces to 1 over 1. 1 times t squared is t squared. 32 over negative 16 is negative 2. 48 over negative 16 is negative 3. So now I've got a is 1, b is negative 2, and c is negative 3, corresponding to my quadratic equation. Plugging that into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. T equals 2 plus or minus the square root of 4 plus 12 over 2. T equals 2 plus or minus the square root of 16 over 2, which is 2 plus or minus 4 over 2. 2 plus 4 over 2 is 6 over 2 is 3. T equals 2 minus 4 over 2 is negative 2 over 2, which is negative 1. So here it reaches the ground 3 seconds later. If we were to extend this graph over here, we'd have at negative 1 for the time, but we can't have a negative time. And in fact, the problem starts right there. So this one doesn't work. But so what is our time? 3 seconds. And again, that's not the time it reaches the maximum height. That's the time when it hits the ground. All righty. Anything else that you want to look at? Okay.
I'm sorry, one more. I
Sure.
wanted to do the last one, the fence one.
This one?
Yes.
Okay. So we've got this rectangle, but we only have 3 sides of it, okay? And the 4th side is made by a river. The first thing I want to point out is that the farmer who's using this is going to lose his herd because the river will not keep the cows in. I'm sorry, they will wander. So it's a bad example from a farm, but sorry, I'm a rancher's son. Okay, but anyway, we've got 3 sides of a rectangle that we're going to build. And we have a total of 1,120 feet of fence. Okay, so we've got to build this side and this side and this side. Those 3 sides have to add up to 1,120 feet. Okay, now, since we're building 3 sides of a rectangle, we can assume that this side and this side are equal. You all right with that?
Yes.
Okay, now, here we have my paper model that represents the 3 sides of the rectangle. So if I unfold this and make it straight, this is a total of 1,120 feet, right? But what if I take off this piece, which is X, and this piece, which is X? What do I have left? Well, I have 1,120 minus 2X. So this side would be 1,120 minus 2X. Because again, the whole thing was 1,120, but I got rid of 2X, so I've got 1,120 minus 2X, okay? So let's call this the width and this the length. And the area of a rectangle is length times width. So area, and I'm going to use function notation, is going to be length 1,120 minus 2X times the width, which is X. All right, which is going to be 1,120X minus 2X squared. We're putting it in a more standard form. We get that. So there's the equation that represents the area of that rectangular fenced-in cow pasture. Okay. Now, they want to know the length of the smaller side and the length of the larger side. So basically, I need to figure out what X is. Okay. This is a 2nd-degree equation. It's a parabola. It has a negative coefficient up front, so it's going to open downward. This axis is X, and this axis is A of X. To maximize the area, I want to find the Y value of the parabola, or of the vertex. That would give me the maximum area, right? It actually doesn't even ask for it. It says, if the enclosed area is to be maximum, find the dimensions. So I need to find X. Well, X is going to be the input value of the vertex, right? So that's going to be negative B over 2A. And in this case, A is negative 2, and B is, oh, I left off an X there. B is 1,120. Okay. So this is going to be negative 1,120 over 2 times negative 2, which is negative 1,120 over negative 4. Negative divided by negative is positive, and 1,120 divided by 4 is 280. All right. Well, let's see if this is 280. This is 280. This would be that minus 2 times 280, which is what, 560, and that's going to be 560. Is that right? Let's see. Yep. So The smaller side is 280 feet. And the larger side is 560 feet. Okay, I want to point something out. Nobody asked about this, but I want to bring it up. And I've actually contacted the WebAssign people, but they didn't see the problem. It says, suppose you are a patrol officer and you have a 304-foot roll of yellow tape, blah, blah, blah. Anyway, the thing of it is this. In this particular problem, let's say that you determine it's a square. Well, if that's true, this is confusing. It has a shorter side and a longer side, and a square would have two equal sides. Sometimes you get an answer that has them, both sides are equal, and so you kind of have to ignore this thing here and just put the same number in for both, okay? So if you get two equal sides and it says shorter and longer, just put them both in the same, okay? All right. Anything else you want to look at before we go? All right, then I am going to stop the recording.